Given the rectangular coordinates negative 1, 1, and negative rad 2, we're going to convert this point into spherical coordinates. Let's look at a quick sketch of where this point is located. We're going to go negative 1 in the direction of x, 1 in the direction of y, and then negative rad 2 in the direction of z to land somewhere down here. Let's go ahead and call that point P. Now we have the conversion formulas that x is equal to rho sine phi cosine theta, y is equal to rho sine phi sine theta, z is equal to rho cosine phi, and another formula that we're going to bring into play is the formula to be used to calculate what rho is. And that can be calculated by simply using the distance formula between the origin and the point in rectangular form. So we'll say, generally speaking, rho squared is equal to x squared plus y squared plus z squared. And rho is actually the first thing we'll calculate. So rho squared is this x squared plus y squared plus z squared. So we get rho is equal to positive 2. Remember, rho is always a positive value, so we don't get the plus minus when we take the square root of both sides. So our ordered triple in spherical coordinates is going to be determined by rho, theta, phi, and right now we already know what the rho value is, so let's go ahead and say that is 2. Now we need to determine theta and phi, and let's go for theta next. To get the value of theta, let's look into R2, essentially the projection of that point into the xy plane, and in R2 we were at the point negative 1, 1. Remember, theta is the same for cylindrical coordinates as it is in those polar coordinates. So we can use the same formula, tan inverse of y over x, in order to get that theta, which is going to be tan inverse of negative 1. Now technically tan inverse of negative 1 is negative pi over 4 because of the inverse function's range restriction, but the angle that we're after is the angle in the second quadrant, which is going to be 3 pi over 4. So that's our value of theta. So we have rho and we have theta. Now to get the value of phi, we could use any of these, although I'm going to use this formula here. So I'm just going to copy our ordered triple down here, and we'll plug in the z-coordinate, which is negative rad 2. We calculated our rho to be 2, and now we'll just solve for phi. But let's remember that the angle phi has to be between 0 and pi. So the angle between 0 and pi that has a negative cosine rad 2 over 2 is also going to be 3 pi over 4. So the ordered triple in spherical coordinates is going to be 2, 3 pi over 4, and 3 pi over 4.